In today's lesson, we'll be taking a look at how we can control FMOD parameters within Unity using C#. We'll also be looking at the difference between a built-in and a user-built parameter in relation to C#. First, let's quickly remind ourselves what FMOD parameters are. Now, they're made up of a range of values that can be adjusted in real time inside our game. These values can be assigned to trigger or just adjust certain conditions within our FMOD events. We can then use our code to control these parameter values and thus the conditions within our events that they control. This allows us to dynamically manipulate our audio depending on specific factors controlled by the player or the game itself. So before we start coding, let's quickly take a look in FMOD at the different types of parameters that we can create. So to demonstrate how to implement parameters into C# and Unity, I've made an event that's going to play a magical hum for the teleporter object at the end of our scene. It uses parameters to automate its low end as well as trigger another sound to play when the player chooses to enter the teleporter. Let's quickly take a listen to how it's going to sound. So as you can hear, this event will loop the audio we've added to it. Now if I increase the distance parameter, you should notice that we not only lose volume, but we also lose low end as the listener moves away from the sound. If I then set the trigger parameter to 1, we have our second sound play and our looping sound fades out, designed to trigger when the player enters the teleporter. Cool stuff! Now allow me to quickly explain how it works if you wish to set up something similar. So in my timeline, I've added the teleporter loop stereo 01 file to the beginning of the first track, which you can find in the assets browser or the audio bin under interactables and teleporters. I've then added a loop region to keep the cursor within the first few seconds of the event and set the instrument containing the event to trigger our sound asynchronously, so that whilst the cursor remains at the beginning of the timeline, the sound will continue to play in full. I then set the instrument itself to loop whilst the cursor is on the instrument, and also set it to cut the playback when untriggered, meaning that when my cursor eventually leaves the loop region and moves past our instrument, the sound inside will be stopped. Now if I click on the first parameter sheet, we can see what I've done with the FMOD built-in distance parameter. Now this parameter is one of 5 for users of FMOD version 1.10.10 or older, and 6 for version 2 and newer, all of which have their own behavior and properties. To create one, all you do is click the plus tab at the top next to your timeline, you click new parameter, then under the parameter type, you select one of the 6 built-in parameters here. And these built-in parameters will work in Unity without us needing to write any extra code that we already have learnt about. All we'll need to do is tell our event when to play, and Unity will feed this parameter the information and calculations it needs to change, depending on which one we choose and what kind of information it needs. If you want to learn a little bit more about the difference between all 6 of them, you can use the link underneath this lesson that will take you to a page in the FMOD documentation explaining them in great detail. So as mentioned earlier, I used the distance parameter to fade out the low end of our loop by automating an EQ that I've added to this track just here. This is so that as the player approaches the teleporter, the low end of our sound will fade in, replicating how certain frequencies travel further than others in the real world.
To automate a value using a parameter, have the parameter sheet at the top selected, and then right-click on whatever value you'd like to automate and choose Add Automation. Once you do that, you'll see this drop-down menu appear underneath your track containing the value that you're automating. This allows you to set that value based upon the values of the parameter you're using by plotting points on the red graph line here. And also to add an effect to a track, you can simply right-click either to the left or to the right side of your fader and then choose the effect you'd like to add.
I then also created my own parameter, which I called trigger, meaning this one will have to be controlled by the code we'll be writing later in C#. Now, as of FMOD version 2.0, there are 3 different types of user-built parameters that you can choose from. For my trigger parameter, I've chosen a discrete parameter, which simply means that the parameter scales up in whole numbers rather than decimal places. Now you could use a continuous parameter for this, if you wish, which for those of you using older FMOD versions is the default and only version, but either way it works just fine. So when this parameter is set to 0, nothing happens, but when it's set to 1, the instrument containing the teleporter walk through 01 file is triggered, which you can find in your audio bin or assets browser under the same folders. If we go back to our timeline and click on the loop region, you can see I've set up a condition that monitors the value of the trigger parameter. So if our trigger parameter is not set to 0, our loop region will release the cursor and the volume of our first track will fade out via volume automation, as you can see here. Once it has and our audio is finished playing, the event will stop. And the final thing I did, if we click on the master track, is just adjust the min and max distance values for the spatializer so that the distance attenuation of our looping fit the dimensions of the scene where our teleporter is located a little bit better. And that's everything. If you've been following along and built it yourself, remember to save your project, assign the event to the master bank, and build your banks with F7. Now that that's all covered, we can take a look at how to play our event in our game. Before we start, let's take a look at the teleporter object we'll be adding our sounds to. So if you double click on the transition start object in the hierarchy tab, you should be taken to the teleporter our player must exit to continue the game. If we take a look at the inspector tab, we'll notice that the box collider component is set to is trigger, which as we learnt in the last lesson means it's acting as a trigger area. So when we create a script for it, we know that we can use the onTriggerEnter function to change our trigger parameter once the player enters it. Before we do any of that, let's quickly change our scene slightly to make our sounds easier to test. So the first thing we're going to do is double click on the Ellen object, and we're actually going to manually change the location of where the player starts by changing the coordinates of the transform component, specifically the position coordinates. So we're going to change X to -146, then we're going to change Y to 21.3, and the Z to -43. And now you can see Ellen will start closer to the teleporter. Let's also find the parent game object for all of our enemy game objects in the hierarchy tab. And let's set it as inactive by clicking the small tick box next to its name in the inspector tab. So this will disable all of the enemies that might try to kill our character. Great, now we're ready to go. Let's make our way to the FMOD folder inside our script folder so we can create a new script. And we're going to call this one F_teleporter, or anything else that you might prefer. Once the script has compiled, let's drag it onto the transition start object, and let's open it up to edit it and start playing our sounds. Okay, so we're going to start by creating an event instance and playing it in the same way we learnt about in the event instance lesson. So at the top, we're going to create our event instance and call it T_hum, short for teleport hum. Then in the start function, we'll create an instance of our teleporter event, and we'll store it inside our new variable. We'll then tell our event to start, and we'll also attach our instance to our game object so that it's recognized as containing a 3D event. Then we'll replace the update function with the onTriggerEnter function, ready to activate when the player enters the teleporter. So it's in here that we'll be writing out our new command called setParameterByName. We're also going to release our instance once it has finished playing, as we'll no longer be needing it once the object has been destroyed. So before we start modifying our parameter to trigger our sound, we want to make sure that only when the player enters our trigger area that we hear the sound play. And this is important because sometimes when using trigger areas, there can be a danger of any unintended object entering and triggering behavior from it that you don't intend to. For example, remember how we disabled the enemies in this scene? Well, the reason why was because a few were located in this area of the teleporter, meaning that if they were enabled again, there is a very small chance that one of them could wander into the teleporter and play our sounds unintentionally. So to prevent this from happening, we need to check for the Ellen game object specifically before we tell our code to adjust our parameter. So in order to do this, we're going to need to pass a reference variable of the collider type through the parameter brackets of the onTriggerEnter function. First of all, it's important not to get these parameter brackets confused with our FMOD parameters that we've created earlier. They're completely different things. So far, we have left these brackets empty whenever we've used or called functions, but now we're going to create a variable inside of them and use this variable to check for the Ellen game object. So let's write inside of these brackets here, collider. which sets the data of this variable as collider, meaning it will only store the information of collider opponents. And then let's give it a name, so we can call it col for short, for example. So this will work for objects containing any type of collider component, such as a box collider, a sphere collider, a mesh collider. Even a rigid body will be accepted by this variable. Now remember from the last lesson, we learned that the game object doesn't have any of these components attached to it, but thankfully it's still able to enter and activate this trigger area thanks to the layer collision matrix that we looked at last time. So this now means that whenever something enters our trigger area, it will need to have a collider component attached for this function to work, and if it does, then we can store information from that component into our col variable. Once this happens, we can find out information from that variable about the object that entered the area. Now in our case, we're going to be interested in the name of the object that entered, but you can access its tag, its transform component, and other information about the object. Now if you want to find out more information about what properties a collider variable can access, there will be another link under this lesson, taking you to the Unity documentation page, listing them in more detail. So let's use this variable to check for the object's name. So in our function, let's write an if statement, and in the brackets we're going to start with the name of our new variable. So now our if statement is going to check the information of the object that entered our area via its collider component. Let's then add the dot operator and write name, specifically checking for the string data inside the object's name field. Finally, we need to compare that string data with the result we're looking for. So let's add two equals operators and write in quotation marks Ellen. So what's happening here is that when something enters our area, our function will first check to see if the object has a collider component attached. If it does, then it will run this if statement, which will check to see if the name of the object the collider is attached to matches the word Ellen. If it does, then our statement will carry out whatever behavior we tell it to. Now, if you're feeling a little bit unsure about the parameter brackets of our function and how it works, I'll be explaining them in more detail in the next lesson. So moving on, we're now ready to change the value of our FMOD parameter inside our if statement. Let's quickly hit enter to write a new line of code that activates when the if statement returns as true. And now in order to set values for our parameters, we first need to choose the instance of the event that contains our parameter, which in our case we know is t_hum. Then we follow it up with the dot operator and write set with a lowercase s, parameter by name, the rest starting with capital letters. And add our two parameter brackets and end it with a semicolon. Now for anyone using a version of FMOD older than version 2.0, which at the time of this recording is the latest one, you'll instead want to write set parameter value like this. So for our command to work, it needs three arguments. It first needs to know the name of the parameter we're going to set a value to in the form of string data or text. And remember, we don't need to change the value of the distance parameter, as Unity will calculate that for us automatically. So instead we'll be writing trigger as a string inside the brackets, just like that. Next, the command needs to know which value we'd like to set our parameter to in the form of float data. Now remember, in FMOD, we set our second audio file to play and our first to fade out whenever the trigger parameter was set from 0 to 1. So we know that when we start our game up, this parameter is going to start at 0 because most parameters start as their lowest value. You can change this by changing the value and then right-clicking and clicking set as initial value. But we want to keep ours like that, just starting as 0, to change to a value of 1 when our player enters the trigger area. We'll also add an F next to our number as we're giving our command a float value. So if you're using set parameter value, you'll only need these two arguments and it should work for you. But if you're using set parameter by name, then you'll need to also feed this command a boolean. And this is to tell our script whether or not to ignore the parameter's seek speed value. If I go back into FMOD quickly and click on our parameter, we get some settings at the bottom to edit, one of which is labeled seek speed. Now this basically allows you to tell your parameter to change to its new value that we've set in our script over a certain amount of time. Now in our case, we want our parameter to change from 0 to 1 instantly, so that the audio inside is played straight away. So we'll be leaving it as its default option, which is instant. Now, if we give our command the false value, our parameter would change using the seek speed, but if left true, it would be ignored and the parameter will change instantly. And because we left our seek speed at its default value of instantly, either way, this parameter will change from 0 to 1 straight away, so it doesn't really matter whether or not we tell it to be true or false. So let's quickly summarize everything that's going on in our script. Before we run the game, we create an event instance variable called thum. By using the start function, we assign an instance of the teleporter event we created earlier to that variable, tell the event to start, position it at the location of our teleporter game object, and then tell it to release the instance once the event has been told to stop. All of this is being done within the first frame of the game. We then use the onTriggerEnter function to check for when something enters our portal and use our col variable to pass information about the object from its collider component into our function. We check to see if the object that entered is named Ellen, and if it is, we set the value of our trigger parameter that is attached to the event stored inside our thum event variable to 1, playing the second audio file within the event and stopping it once it's finished. Great, now all we need to do is save our script and listen to how it sounds. Just quickly jump back into Unity and let's play our scene. So as you can hear, whilst the player is standing far away from the teleporter, they are able to hear it, but it doesn't have a lot of low end and sounds quite distant. Now if we start to approach the teleporter, we should hear that low end come in. And then if the player enters the teleporter, we hear that second audio file play. And now as Unity loads into a new scene, it will destroy all of our game objects in the current scene we just left, including our teleporter object, and also the instance of our event we created within it. Great, so to recap, we've learnt that we don't need to write any code to use FMOD's built-in parameters with our events. We know how to use an in-game action, such as the player entering a trigger area, to set a parameter. And we also now know how to use the .setParameterByName command to change the value of our parameter during runtime. And there's more to discuss about FMOD parameters, but in the next lesson we're going to take a little break from parameters to first learn how we can hook up our events to Unity animations.